All right, hello people. Got another spectacular physics problem here. So for this one, apparently me and you are in some kind of race. I'm told the details of where I'm going to drive, and then you're going to drive there into that same location, but in a different manner. And we want to know who will arrive first, and by how much time. Okay. So, let's figure out this location first. So it says I drive my car due northeast for 1 kilometer. After this, I drive north at 20 meters per second for 30 seconds. So the point is somewhere up here. So I'll call this the first leg and this the second leg. I can come up with a vector for the first leg. This vector I know has a magnitude of 1 kilometer. Um, because they tell us I drive my car northeast for 1 kilometer. And better yet, I know this angle. This angle is 45 degrees. Right, right in the middle because I say due northeast. So then we just need to find our x and y coordinates. So this vector will be 1 times the cosine of 45, comma, 1 times the sine of 45. And all I'm using here is x equals r cosine of theta and y equals r sine of theta. And then right now I have this in kilometers. So the cosine of 45 and the sine of 45 both give me 1 over the square root of 2. So then converting to meters, I will get d1 equals 1,000 times 1 over the square root of 2, comma 1,000 times 1 over the square root of 2. And this equals about 707, comma 707. Okay, so that is our first vector, d1. So now I can describe the second vector, d2. I'm driving due north, so I'm not going to move at all in the x direction. And I'm given the velocity and the time that I drove at this velocity. So it's going to be vt, v naught times t. And in this case, for us, it'll equal 0, comma 20 times 30, which is 0, comma 600. So now I can express the total displacement vector. I'll call it big D equals D1 plus D2. And this equals 707, comma, and then adding these two up, I'll get 1307. Okay. Now, it says you are driving from rest directly to this location. So here's what you're doing. You are moving exactly in that direction. So really, the total distance that you will have to cross is the magnitude of this guy. So the magnitude of D is going to be kind of big. Square root of 707 squared plus 1307 squared equals 1485. Okay, so now I can express your position directly along this path using my kinematics. X of t equals at squared over 2, although it's not really x here, remember, because we're moving directly along this line. So I want the distance, 1485 equals, and then the only way you're going to cover ground is through that acceleration. So this will be at squared over 2. And it says you are accelerating at, what was it, 2? You are accelerating at 2 meters per second squared. So 2t squared over 2 equals t squared. So now I can solve for the time that took you to get there. The time for you equals the square root of 1485, which equals 38.5 seconds. But we also need to know my time. So the time for me, well, we're told the distance for this second leg, or the time for the second leg. We're told it's 30 seconds there, so it's going to be 30. And then for the second leg, we have a distance and a speed, so I can get a time. So the time will be the distance, which was 1,000, divided by the velocity, which was 40. So this gets me 55 seconds. So it appears that you have beat me. Well done.